Yes, dear students, TPS Pilani welcome to you. Now we are going to start our topic, and in our topic we are going to start exercise number 9.7. And before starting it, we have to prove some formulas. So first of all, we are taking first formula. This formula is I equal to integration of under root x square plus a square dx. Now we have to integrate it. Suppose this is a question, not a formula, and you have to take 1 the second under root x square plus a square into 1 dx. This is first and this is second function. Now under root x square plus a square integration of first 1 dx minus dy by dx first under root x square plus a square integration of second 1 dx whole dx. It is equal to x square plus a square whole under root into integration of 1 equal to x minus dy by dx under root 1 x square plus a square. This is equal to 1 upon under root x square plus a square into x square dy by dx of x square 2x and integration of 1 equal to x dx. Next, it is equal to under root x square plus a square into x minus 2 can be taken outside of integration because it is constant, and it makes x square when multiplied and upon x square plus a square. A square can be added and can be subtracted from numerator so that it can be changed into standard form. Now x under root x square plus a square minus 2 integration of x square plus a square upon under root x square plus a square dx minus a square 1 upon under root x square plus a square dx. All brackets closed. Now it is equal to x under root x square plus a square minus 2, and if we divide this into, if we divide, then it will become under root x square plus a square. Yes, today here we have to write 2 and 2 cancelled by 2. So there will be no 2 because 2 integration of under root x 1 upon 2 under root x. I have written only 1 upon under root x square plus a square, which is wrong. Then I have to put 2 and we have to remove it from here, and this is also not here and it is also be removed from here. Now minus a square integration of 1 upon under root x square plus a square dx. We can remove the bracket. It is equal to x under root x square plus a square minus integration of under root x square plus a square minus plus and integration of this, you know, this is a standard formula and it is equal to log x plus under root x square plus a square plus c can be written. Now it is equal to x under root x square plus a square minus, this can be written I because this is your question and it is equal to I. That is why instead of it we can put I. And the next term a square log x plus under root x square plus a square plus c and I, and this is equal also to I, then it will become 2I equal to x square plus a square log x plus under root x square plus a square plus c, and 2 can be divided. I equal to then x by 2 under root x square plus a square log x plus under root x square plus a square plus c. This is the value which can be put instead of integration of x square plus a square. This is the standard formula, and instead of this we can put this. Now again I explain you how to prove it. It is given this is under root x square plus a square. We have to integrate it, and second function we have taken 1. Then 1 is first, this is first and 1 is second according to Euler rule. And then x square plus a square first integration of second dy by dx, first integration of dx or dx. After that integration of 1 x dy by dx of x square plus a square equal to 1 upon 2 under root x square plus a square, and of x square plus a square equal to 2x, and integration of 1 equal to x. 2 cancelled by 2. By the way, I have not put 2 here by mistake. Then the 2 was present here, but at the time it is removed from here because it is cancelled. Then it is equal to x square upon under root x square plus a square. We have add and subtract a square, which is add and subtracted. Now it is equal to denominator upon this and denominator upon this. We have separated it. Now if we divide this, then the value will be under root x square plus a square, because if 2 upon under root 2, then 2 can be written as under root 2 upon under root 2, and under root 2 cancelled by under root 2, then only 2 will be remained. Like the same, it is also will be remained x square plus a square whole under root minus a square, which is constant, can be taken common, and then it will be 1 upon x square upon a square. This is standard formula, and its integration of this is equal to log x plus under root x square plus a square. Now we remove the bracket, and then it is equal to x under root x square plus a square and minus this can be written as same and minus minus it is plus and integration of this equal to this by formula. And now it can be written as I because this is your original question and it is written here under root x square plus a square dx. That is why it can be written as I because it is equal to I. And I, when it will be transferred to left hand side, then it will become I plus I to I. And 2I equal to x under root x square plus a square log x plus under root x square plus a square plus c. And if we divide both of the sides of the equation by 2, then we find this. And this is your standard formula which can be put instead of this. Like the same, there are two formulas other which I sent you yesterday in PDF, and I think I should explain one. Then one formula I have explained you, and other two you can similarly solve according to this because the process is the same. That is why there is no necessity, and PDF also have been sent. Now we are going to take second formula of this exercise. Like this, there are three formulas. What are other two? This is first, and second is under root x square plus a square minus x square dx, and third is under root x square plus a square minus x square, and a square plus x square is taken a square minus x square minus a square. This is third. There are three formulas like this. One is proved on the blackboard, and like the same, this is second and this is third. You can prove them like the same or similarly, which is written on blackboard. And now we are going to take the next formula. I equal to power of Ex sin Bx dx. This is like a question. We are taking it like a question, and according to I let, this is first and this is second. Now taking sin Bx first and sin Bx second, we are going to start it by formula. First, sin Bx integration of second power of Ex dx minus dy by dx. First, sin Bx integration of second power of Ax dx or dx. And you know integration of Ex sin Bx as it is integration of Ex equal to Ex upon A. You know it very well, because now this chapter is in end. That is why You must know about it because all the integrations you have to write. dy by dx sin x cos bx or into b dy by integration of power of ex. Ax is power of e and integration of this is equal to power of ex upon a dx integration. Now taking b upon a outside integration because it is constant, power of ex upon a sin bx minus b upon a e power of e ax cos bx dx. Now again this is also a question and taking first and second, this is first and this is second. Again apply the same formula and now it is power of e ax upon a sin bx minus b upon a first cos bx integration of second power of ex dx minus dy by dx first cos bx integration of second power of ex dx or dx, and it is equal to power of ex upon a sin bx minus, now remove this bracket, b upon a cos bx power of ex, then integration of this e power of ex upon a minus b upon a and minus minus plus dy by dx cos bx minus sin bx and integration of power of e ax e power of e ax upon a dx, and b will be also here because cos bx sin bx minus sin bx and of bx equal to b. Now this is equal to power of ex upon a sin bx minus b upon a cos bx b upon a square or into power of ex this a, it will become a square when a and a multiplied, and this is equal to minus b square upon a square, and this is equal to I because sin bx power of ex, this is your question, and it is equal to I, and we have taken b upon a outside it, then it is equal to b square upon a square. Now it is equal to I plus b square upon a square I equal to power of e ax upon a plus minus b upon a square cos bx sin bx minus b upon a square minus b upon a square cos bx into power of Ex upon power of Ex only. It can be taken outside B upon A, and this is equal to A upon B. This is equal to A square plus B square upon A square. Equal to power of Ex upon A sin Bx plus minus B upon A square minus B upon A square cos Bx. I equal to, we have to multiply it by taking common A square, 1 upon A square power of Ex sin Bx, or into A minus B cos Bx I into A square plus B square upon A square equal to I equal to A square into A square plus B square into 1 upon A square, and power of Ex can be taken common, A sin Bx minus B cos Bx, and this cancelled by this, then it is equal to 1 upon A square plus B square power of Ex upon A square plus B square A sin Bx minus B cos Bx plus C. This is your standard formula which is proved, and you have to take first and second and have to prove. This is sufficient for today, because now there are other formulas which we have to prove, but we have not so much time that we can prove it. Then all other formulas will be explained to you tomorrow. Now, thank you very much.